So I'm going to start with a very brief intro about TRI, who we are, the things that we do, our mission, and then I'm going to dive into two technical methods for monocular depth estimation based on our most recent publications. So about our mission, TRI envisions a future where Toyota products enabled by TRI technology dramatically improve the quality of life for individuals and society. And our role at TRI is to build this technology that's going to lead to the creation of these future products. And more specifically, in the Large Behavior Models Division, or LBM, our goal is to build general-purpose robots which can help people with daily tasks in typical environments like supermarkets, homes, factories, and things like that. And I'm going to show you a video that highlights some of these environments and also the kind of capabilities that these robots need in order to be able to be successful at the tasks that they have to achieve. So there are two different snippets. The first one is a typical supermarket-style application where the robot basically has to drive around, find objects, pick them up, interact with them, drop them in baskets, and so on. And then also a very short snippet showing a factory-style robot that has to interact with totes, pick them up, move them around, and so on. And so, as we saw, these robots, in order to be successful, they have to act with the world. And in order to act in the world, they have to be able to perceive it. And the task that I'm going to talk about in this presentation, which is an enabler for this capability, is the ability to estimate monocular depth from camera images. And I want to take just a minute to define this task. So basically what this boils down to is we have as input a camera image. And what we want to do is we want to estimate for each pixel in the camera image the corresponding depth measurement for that pixel along the ray that connects that pixel with the camera center. And once we have all of these predictions, we assemble them into a depth map, and then we can use this depth map prediction for a wide range of downstream tasks, like finding the distance to objects, clustering points in 2.5D, creating point clouds, so lifting 2D information from images into 3D and creating point clouds using camera intrinsics, and so on.